Hello friends, we just finished talking about in our last video about factoring a greatest common factor, what that meant, how we applied it to a polynomial, how we applied it to a bunch of different terms. So now we're going to go on, I mentioned that this unit is all about factoring quadratic expressions. So we're going to go in to some preparation steps in order to help us to be able to better and easier factor quadratic expressions. We'll get into why we factor quadratic expressions, where this is used in the real world, etc., etc. So, by the end of this lesson, I hope that you're able to put a quadratic expression in standard form. This isn't new information, but we'll review it. That you're going to be able to identify A, B, and C of a quadratic in standard form, what those terms are and what they represent. And then given A multiplied by C, and then B, this is going to be a number, this is going to be a number. And this is a big part of this lesson. I want you to be able to find two numbers that multiply to give you this number and add to give you this number. So that's what we're going to do today. If you're a little confused as to why we're doing that, that's okay. It's all going to come together throughout this lesson and the next. So, excuse me. When we talk about a quadratic expression, this is something that we've already discussed in this last unit when we were talking about graphing. A quadratic function is one that looks like this. If I had a quadratic function, it looks something like a u, and the function has an x squared in it. It might have a bunch of other stuff, but it has an x squared, something squared. So a quadratic expression basically is a polynomial of degree 2. If you remember way back to Unit 2 when we talked about polynomials, a polynomial with degree 2 means the biggest exponent, the largest exponent, is 2. So I have x squared plus 4, x squared plus 3x minus 8, 4x squared plus 8x minus 12. All those are quadratic expressions because their biggest exponent, the biggest exponent on the x's, is 2. So those are the expressions that we're going to get real comfortable with for really the next 3 units. This is what we are going to be dealing with for the next 3 units, because quadratic expressions pop up a lot in real-world problems, and a lot of problems that we see in physics application, in chemistry application, in profit analysis application. Lots of situations like that we see quadratic expressions. So this is why we talk about it. So, I've been using this word factoring a lot. So we can change a quadratic expression in standard form, so something like this, x squared minus 5x plus 6, to factored form by factoring or undistributing, in quotation marks here, the equation. For example, these two expressions right here are equivalent to each other. They're equal to each other. This would be standard form, and this would be factored form. So just to convince you that these are the same, let's take these two right here and multiply them together. So now we're kind of going back again to what we learned about in Unit 2 when we were talking about polynomials, multiplying two different polynomials together. So if you use the box method, this might be ringing a bell. If you use the box method, you're going to put x minus 2 up here, x minus 3 on this side. I'm going to go ahead and use the rainbow method. So I get x squared minus 3x minus 2x plus 6. And then I can combine these x's together and I get x squared minus 5x plus 6. So these are equivalent expressions. They're exactly the same, just one is factored and one is in standard form. One is undistributed, one is distributed or multiplied together. So what we've gone from this form to this form a lot in Unit 2, back when we were talking about polynomials, we've done this before. This whole unit is going to be about going from this form to this form and kind of how we go about doing that. And again, later on in the lesson, I'll explain why do we do this, why are we talking about quadratic expressions, why is it helpful to factor them. We'll get to that later in this unit. So notice in here, in the factored form of this expression, negative 2 times negative 3, negative 2 times negative 3 is equal to 6. I had to get that when I did my last little step of my distributing. Negative 2 times negative 3 is 6. And then notice that negative 2 plus negative 3 is negative 5, because I had negative 2x minus 3x. When I add those together, I got negative 5x. So pay close attention to that. That's going to come in handy with the next few problems that I do, and then especially in the next concept. This is going to come in really handy to be able to recognize this structure, how these quadratic expressions are set up. Okay, so this is the standard form. Again, put that in quotation marks if you want. This is the standard form of a quadratic expression. Ax squared plus bx plus c, where these right here are just numbers. 1, 2, 3, or 5, 6, 7, or whatever. A, b, and c are just numbers. A is in front of x squared, b is in front of x, and c is all by itself here. So the instructions here is, and again, if you haven't already yet printed off the guided notes or have the guided notes available for you to look at, this is all in your guided notes for you to be able to follow along. But it says, put the following quadratics in standard form and list A, B, and C. Again, standard form is going from the biggest exponent to the smallest exponent. From the biggest exponent to the smallest exponent. So for right here, for example, this is the term with the largest exponent. So I'm going to write that one first. This is the term with the next largest exponent. I'm going to write that one second. This is the one that doesn't even have an exponent because it doesn't have an x in front of it. I'm going to write that one last. So then if I'm going to write my A, B, and C terms, this is A, this is B, and this is C. Just like that. And for now, that's all we're doing. I just want us to put the quadratic expression in standard form and find A, B, and C. Now, how about this one? This one, you'll notice, is already in standard form. So A is 4, B is negative 2, C is negative 6. Straight up, pretty straightforward. This one, to put in standard form, I'm going to put x squared plus 2x minus 9. A, notice that there's nothing in front of here, so A is just 1. A is 1, B is 2, C is negative 9. So sometimes you'll have the situation where you have A is equal to 1, or B is equal to 1, or C is equal to 1. Whatever, that's fine. Just remember when there's not a number in front of a variable, it's assumed that it is 1. Okay, so we're going to take a sabbatical from that here for a minute. So to help us learn to factor quadratic expressions, we're going to practice something. I really like this. This next process is kind of like a puzzle to me. It's kind of like a little game. So I really appreciate this and enjoy this. What we're going to do is we're going to find two numbers that multiply to equal the number in the first column, and then sum or add to equal the number in the second column. So I need to find two numbers that multiply, for example in this problem, two numbers that multiply to make 14, and two numbers that multiply to make, let me start over. Two numbers that multiply to make 14, and then those same two numbers need to add to make 9. You should make a game about this, like a Sudoku game, where they just give you a bunch of numbers. You have to find two numbers that multiply to make one of the numbers, and add to make another one of the numbers. So this is how I go about finding two numbers that multiply to make 14 and add to 9. So I'm going to list all my factors. Factors, see that word again? Find all my factors of 14, or all my sets of numbers that multiply to make 14. Well, 1 times 14 is 14. 2 times 7 is 14. And that's it. That's it. Sorry about that. They started playing something over the intercom. Okay, those are the only sets of numbers that multiply to make 14. Whoops. But wait, is it? What about negative 1 times negative 14? Or negative 2 times negative 7? Negative 1 times negative 14 is a positive 14, because a negative times a negative is a positive. Negative 2 times negative 7 is positive 14, because negative times a negative is a positive. So every set I have these positive factors, 1 times 14 and 2 times 7, I also have these negative factors, negative 1 and negative 14, negative 2 and negative 7. So now I need to see which of these sets of numbers, when I add them together, is going to give me 9. 1 plus 14, 2 plus 7, negative 1 plus negative 14, negative 2 plus negative 7. Okay, 1 plus 14 is 15, 2 plus 7 is 9, negative 1 plus negative 14 is negative 15, negative 2 plus negative 7 is negative 9. Well, there we go. 2 plus 7 is equal to 9. So my two numbers that add up to 9 and multiply to make 14 are 2 and 7. 2 times 7 is 14. 2 plus 7 is 9. Okay, now we're going to do that same thing with these ones. This one number is a little bit bigger, but the process is exactly the same. I'm going to find two numbers that multiply to make 200 and add to make 33. So let's see, I have 1 and 200. I have 2 and 100. I have 4, well 3 wouldn't work. It wouldn't go in evenly, so I have 4 and 50. I have 5 and... See, I have to start getting my calculator, and that's fine. 5 and 40. 6 won't go in evenly, 7 won't. 8 and 25. 8 and 25. There are a few more. I'm going to stop right there, though, because that's all we're going to need. Also, there would be -1 and -200. -2 and -100. -4 and -50. -5 and -40. -8 and -25. All of those would multiply to make 200. There's a lot of factors. And if, when in doubt, go through with your calculator. And you can use your phone calculator or Desmos calculator. 200 divided by 1 is 200. 200 divided by 2 is 100. 200 divided by 3 will not give you a whole number, so we're not going to use that. 200 divided by 4 is 50, etc., etc., etc. Sometimes it's just a trial and error, finding as many numbers as you can that multiply to 200. Now, I'm going to add these together and see which one of them is going to give me 33. Okay, there's 201, 102, 54, 45, 33. Oh! Right there. 8 plus 25 is equal to 33. So my two numbers that multiply to make 200 and add to 33 are 8 and 25. Okay, that's what we're doing here. So I'm not going to do, well, actually I'm going to do one of these. Sorry. Okay, so I'm finding numbers that multiply to make -32 and add up to 4. So let's find some factors of -32. Keep in mind that in these factors, so like maybe I have 32 and -1. One of these factors are going to have to be negative if I want them to multiply together and give me a negative number. So 32 and -1, 16 and -2, 8 and -4. I think that's all of them. And then I'd have -32 and +1, -16 and +2, -8 and +4. Notice my two columns of numbers here where the signs switch. 32 plus -1 is 31. 16 plus -2 is 14. 8 plus -4 is 4. 8 plus -4 is 4. So my two numbers that multiply to make -32 and add up to 4 are 8 and -4. So I'll leave this one for you to try on your own, but that's what we're doing here. That's what we're trying to accomplish. So again, if you want to go back and pause that video so you can look at that a little bit closer, try one of those examples on your own, feel free to do so. So now we're going to take another step here. Whoops, sorry. Let me get my pen back. So now we're going to take a look at these quadratic expressions. So, given these quadratics, I want you to list what A times C is, and then what B is, and then find two numbers that multiply to make AC and add to B. Watch and learn. See this. You're going to be fine. So remember, in a quadratic in standard form, the first term is A, the second term is B, the third term is C. A times C is 3 times 4, which is, 3 times 4 is 12. And B here is -7. Okay? Good. So, now, this is basically just the number in my first column. This is the number in my second column. So if I go back in here, I was trying to find two numbers that multiplied to make -32 and add to 4. Here I'm finding two numbers that multiply to 12 and add to -7. So I'm going to make a list of all the factors of 12. So I have 1 and 12. I have 2 and 6. I have 3 and 4. And then I have -1 and -12. -2 and -6. -3 and -4. Those are all my factors of 12. Because 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and conversely with all of these negatives. So now I need to find out which of these pairs, when I add them together, is going to give me -7. So here I get 13, 8, 7. Here I get -13, -8, and -7. So the two numbers that multiply to make 12 and add up to -7 are -3 and -4. See that? See that? And you can test it. -3 times -4 is indeed a positive 12. And -3 plus -4 is indeed -7. Okay. Let's do another one. We'll do a couple more. We're going to drill this in because this is going to become so helpful later. Here, A, B, C. So A is 1, B is 8, C is 16. So I'm trying to find factors of 1 times 16. So I'm trying to find factors of 16 that add up to 8. And you'll probably start to notice you might be able to start think of these numbers right off the bat without listing them all off, but I'm going to list them off for those who benefit from this. So my factors of 16 are 1 and 16, 2 and 8, 4 and 4. Also, -1 and -16, -2, -8, -4, -4. So I'm going to add all these together, and see which pair gives me an 8. 1 plus 16 is 17, 2 plus 8 is 10, 4 plus 4 is 8. So two numbers that multiply to make 16 and add to 8 are 4 and 4. Okay, let's do one more. I'm going to put this over here, trying to block off as little as possible. So here, let me get my pen back. So here is my A, B, and C. So A times C is 2 times 6, which is 12, and B is 8. Well, this is convenient. I already have the factors of 12 over here. So I need to find factors of 12 that add up to 8. There it is. 2 plus 6. That's ironic. Those are those same numbers right here. So the two numbers that multiply to 12 and add to 8 are 2 and 6. This next slide I want you to try on your own. Maybe pause the video, take a look at some of these. But multiply A and C together to get a number, then find B, and then find two numbers that multiply to make this number and add to make this number. So that's what I want you to do after this lesson. First, I want you to be able to put a quadratic expression in standard form. Once it's in standard form, I want you to be able to find what A, B, and C are, those numbers. Then I want you, given that you can multiply A and C together and find B, be able to find two numbers that multiply to make this number and add to make this number. This is going to come in real handy in this next lesson where we talk about factoring quadratics. So have some fun with this. I really think this is like a little puzzle. I enjoy it. I hope you enjoy it too. I hope that's helpful. Again, we're going to talk about in the upcoming lessons why we do this, why we're factoring quadratics, where we use it. But I hope that you enjoyed that video as much as I did.